Okay, so we talked about factoring and taking roots, a couple of different ways to factor. Now we're going to complete the square. Okay, so this is a skill that you'll need as you go through calculus. So the idea here is this equation is given as x squared plus 2x equals 8. But if it looked like a normal quadratic equation where it was set equal to 0, then we would make it look like the given one. We would get that 8 over there. Okay. So the idea here is to, even if it's not given like that, to make it so it's your x squared term and your x term are on the one side of the equation. Okay, so the idea is to create what's called a perfect square trinomial, something that will factor as a perfect square, a linear factor squared. So what will always work is you take half of this number and square it. That is, as long as this is 1, the coefficient of x squared is 1. If that wasn't the case, if there was a 6 here, we'd divide everything by 6. But in this case, we're given coefficient 1. So we're going to take half of the coefficient of x term and square it. So half of 2 is 1. And if we square that, we get 1. Okay, so that'll be the formula. So I got to add 1. So now I created a perfect square trinomial, x squared plus 2x plus 1. I'm going to be able to factor always, if I take half of that and square it, I'll always be able to factor that as a perfect square trinomial. Now, we added 1 to the left, so you know your algebra, you got to add 1 to the right. Okay, so what's a perfect square trinomial? Well, when we factored before, we said find two numbers that multiply together to give you 1 and add together to give you 2. And those two numbers are 1, the same number. 1 times 1 is 1, 1 plus 1 is 2. So you can go right into that squared linear factor. So that's what I mean by this is a perfect square trinomial, because it factors like that, something that's been squared. Okay, now the last step will be to solve by taking square roots. The goal is to solve for x. So we square root both sides, do your plus or minus thing. The square root of something squared, those cancel out. The square root of 9 is 3, so I get a plus or minus 3 here. And then my final answer will be, I'm going to subtract 1 from both sides. X equals -1 plus or minus 3. Okay, now if this wasn't a perfect square as well, the 9, let's say that was a 5, then you'd be done. Your answer would be -1 plus or minus root 5. And that's the best you can do. In this case, since I can add 3 to -1 and subtract 3, then I'll have two answers, right? Take the positive 3 to give you one answer. Take the -3 to give you the other answer. Those would be your two answers, okay? Be aware we can get square roots or i's out of there as well. If that were a -9, then this would be 3i. All right, if that were -20, then you'd have to, if this ended up being a -20 under the radical, then you'd have to simplify it, right? That would be I times 20, and that would be I times root 4 times root 5, 2i root 5, okay? So in other words, this can be anything. When I move a number over here, doesn't matter what it is, I can do this completing the square. I can deal with both complex and real solutions. So you'll notice for this one, we got two nice answers, which means it would have factored. So if I go back to here, then that means I could have found two numbers that multiply together to give me -8 and add together to give me 2. It should be +4 and -2. Those will multiply to get -8 and add to get +2. And then if we continued on and set both to 0, we would get +2 and -4 as solutions. Okay? All right, how about this one? So your choices, so now it just says solve for x. So you would have those four choices. Taking roots, can't do that because we have a x term. I could try to factor, but I don't think that's going to work because two numbers that multiply together give me 4 and add together to give me -1 don't exist. So I can't factor. So I'm on to either completing the square. So the choice is yours. Complete the square. Or the last guy that we haven't talked about yet is the quadratic formula, which looks like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So if I can complete the square like we did in the last one, I'd move the 4 over. Here's the problem. I don't really want to complete the square. I would take half of this and then I would square it. Half of 1 is a half. Squared is a fourth. So that number completes the square. But I don't want to do that if I don't have to. I don't want to deal with that fraction. You can, but I'm just going to go to my formula. When in doubt, use the quadratic formula, right? It'll always work. Again, if this is, you can get imaginary numbers. If the discriminant, b squared minus 4ac, is negative, then you have an I in your answer. So we'll see what happens in this one. X equals, so a is 1, b is negative 1, c is 4. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. 1 plus or minus the square root of 1 minus 16, negative 15 over 2. Okay, good. We got an ugly answer. I'll expect you to give me the I, at least pull out the I. So remember, the square root of negative 15 can be written like that, right? The square root of negative 1, I, times positive 15. So I can go that far, plus or minus I root 15 over 2. And that's the best I can do because I cannot reduce root 15, right? You can break up root 15 as root 5 times root 3, but neither of those have a root. They're not perfect squares. So this is the best I can do. This would be acceptable for me on a written test. You'll have to watch the computer. It might want you to break those up. It might tell you, write your answer in a plus bi form, because that's how we write complex answers a lot. So what I would do is kind of break that guy up. So the 2 goes into both of those. And how do you write that? Well, usually you would write the real component, and then in this case, you put the I at the end of the fraction. Okay, so just be aware of that. The computer sometimes might be a little picky. That's why one reason I give you multiple choices. Multiple attempts, rather. Okay, find the zeros of the function. So why is this in the solving quadratic equations section? Well, to find the zeros of a function, what you do is you set your function to 0 and solve. So I know I just jumped to topics of functions, which we'll talk a lot about in here. But to find the zeros, you find the x values for which the function is 0. Algebraically, you set your function to 0 and solve. Okay. So now I got a quadratic equation, and now I got choices. I can't complete the square. I could do the formula. I could try and factor. I'm going to try and factor. I like to factor. AC equals negative 20. If I can find two numbers that multiply together to give me negative 20 and add together to give me negative 2, then I'll be able to factor using that AC method. And I think if I investigate 10, I thought I could do it, but maybe not. 10 times 2 is 20, but you'll never get negative 2. What else? 4 and 5. That's not going to work. Okay, good. So in this case, I'm just going to go right to the formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c. Attempt to factor failed. That's okay. We got other methods. Negative b plus minus square root of b squared minus 4 times a times c all over 2 times a. And those are my zeros. Okay, so let's see if they're real. If this ends up being a positive value, then I'll have two real zeros. The zeros of the function, that's where they cross the x-axis along here somewhere. If they're imaginary, then this quadratic never crossed. It was either up here or down here. But it looks like they're going to be real because I got two negatives. So I got a 20 times 4, that's 80 positive, plus 4. I'm going to check my math on that one, over 10. 4 times 5 is 20, times 4 is 80, plus 4 is 84. 20 times 4, 84. Okay. That should be a 4. Okay, now, if we were graphing this, we might want these as decimals. But first, for practice, like I said, you got to be able to give me both a reduced exact solution and decimal values. So I would say, let's see if we can see this over here. The square root of 84, if there's a perfect square that goes in 84, we got to reduce it. I know 4 goes in there, and it goes in 21 times. So I think that's how that works. And I know 21 does have factors 7 and 3, but none of them have square roots, okay? So that means I have 2 plus or minus the square root of 21 times 2 over 10, and we can reduce that. If there's a number that goes into those 3 numbers, not the one under the radical, then I can reduce this fraction. So that would be, take 2 into all of those, 1 plus or minus root 21 over 5, okay? So that's my exact solution. Now remember, if you wanted to graph these guys, you might want to get your calculator out and do that. 1 plus root 21, enter, divide by 5, enter, and that'll give you one of your solutions. The other one would go 1 minus root 21 over 5. So 1 minus the square root of 21, enter, divided by 5, enter, and that'll give you a decimal. That one should be negative something. And if we were to graph it, maybe something like that, okay? But find the zeros of the function closely related to solving quadratics, because the first thing you do is you set your function to 0, and if I have a quadratic function, then I end up with a quadratic equation. Okay. Oh, we just did that. Good. All right. So now we're going to the next video we'll do the other section. Rationals, roots, and absolute value.